Today I will show you my lathe electronic lead screw type 2, that is the replacement for the transmission mechanical gears. My previous videos, ALS type 1, touchscreen display and ultrasonar end stops, explains the basics and my design intent. Newly added internal necessary features to complete this ALS type 2 are automatic switching between ALS and CNC, end stops chuck and tail, fault warnings, beeper stall and errors, touchscreen display support with protections, over, under, reverse surge voltage protections, current protection, temperature protection. This ALS system kit is a complete working unit that does not need other components or modules to work correctly. This is my lathe electronic lead screw, in short ALS, with a polyester scratch resistant top layer. In the multicolor layout there is a DC power plug 24 to 34 volts, 5 amps, and essential connections on the left. The motor stepper signals with LED indications for step, deer, enable and alarm, voltages and errors indication LEDs, replaceable fuse on the top, internal beeper for stepper alarm, and stop is a separate dedicated circuit for the LED displays here and here that can work without the microcontroller, and that beeper is in my ultrasonar and stop module to never fail. Switching stepper signals and end stops from ALS to CNC with this slide switch. TMC board buttons for power, set, forward and reverse, feet and tread, millimeter and inch, increase and decrease values. 2 displays for RPM and feed rate, 8 indication LEDs for the button selections, microcontroller, run and download positions, for PC micro USB programming with dip switches on the right for external isolated power selection. The ALS controller default firmware can be found on the site from Claw 42 and Kent van der Velde. Only use a sufficient power supply with DC power plug 24 to 34 volts, 5 amps, that will be checked internally by ALS with over, under, reverse and surge voltage protections. Flat cable to the isolated stepper driver and power to the stepper motor. End stop connections also for the optional CNC to the ultrasonar or laser end stops. Touchscreen protected connections, rotary encoder connections on the bottom, motor signals from CNC to the ALS on the bottom. Indication LEDs for voltages and errors while increasing input voltage. I'm going up and some LEDs are flashing until the 24 volts, 20 volts, 23 and 24, and then it's going on. Now I'm going up to 34 volts, 33, 32, 33, and then 34, then per tenths 34.2 volts, and it's shutting down. When I'm going back to lower than 34 volts, it will switch on again. The TMC user interface and the touchscreen with RPM and feed display works as shown in my previous video ALS type 1. I can increase the value also on the touchscreen I can increase it also with these buttons on the touchscreen and decrease it, also decrease it here. I can switch between millimeter and inch, right hand, forward, right hand, left hand, forward, reverse. Programming Texas Instrument board with the dip switches is on the right. See my previous video ALS Type 1. Switching stepper signals and end stops from ALS to CNC with this slide switch. And then this changes. Everything is going out and only this is on power for the CNC support. And back again. And now the CNC is shut down and only the ALS is working. With the rotary encoder, the RPM is going up on the TMC board and on the touchscreen. Latch for the stepper motor signals will flash when the rotary encoder and the motor rotates. Selection which end stop, chuck or tail, to activate with the top dip switches. You can push them down, select just one, the tail up for on, or only the chuck is on. But now for the demonstration I will put it both on. When I switch the end stops to on, it will flash red-green for programming the left and the right limits. So when this is my carriage and I want this to be my left limit, I press the left button and now it's programmed that when the carriage is going to the chuck, it will beep, and when it's going to the other side it won't beep. When I want this to be the right limit, I press the right button and now it stays on green to indicate that both limits has been programmed. So when I'm moving in between the two limits there's nothing happening, but when I'm coming too close or too far it will beep. Between. And that's it. The ideal situation is feeds and threads with the ALS or SSV. But starting with the lathe, just use alternatives first. For feeds, you can use the feed rate selector knob ABC. For common threads, use cheaper and simple way with tabs and dies in combination with, respectively, tail drill chuck and the tailstock thread cut die holder. In not frequent rare situation, once a month, where some exceptional unique threads are needed, just change the mechanical gears manually with the gear table on the lathe and use a thread cutter tool instead. The ALS or SSV is then unnecessarily complicated and expensive to implement. In frequent situation once a week, where many common and exceptional unique threads are needed, then changing the mechanical gears manually and the use of a thread cutter tool becomes quite annoying. To get the gears running smooth without wear and noise is quite a challenge every time. The ALS is then the perfect cheap solution to implement instead of buying a new gearbox lathe. With my ALS Type 1 and 2 for hobby, amateur and engineer, then an open loop or closed loop NEMA 23 stepper with driver is sufficient for common speeds. For professionals, frequent high speed work and very long threads on a large lathe, then a closed loop hybrid servo NEMA 23, 34 could be better. But often those large lathes already have a feed thread gearbox with selection handles. This depends on your situations, expertise, future needs in work and budget. Do you want a do-it-yourself unit, a compact unit with optional upgrades, or a total solution with end stops, fault detections for missing steps or other motor faults, CNC option, small touchscreen color display? Then you have 3 ALS options: the ALS Original, ALS Type 1 and ALS Type 2. You need the Shield Boost XL PCB from Claw42 and buy all other parts with his YouTube videos affiliated links in online stores. You also need an electronics enclosure for the power supply with fuses, DINs, rails, fans, buttons, switches. See his videos. Overall size is very large, but robust. Much expertise in do-it-yourself work on electric wiring and mechanical work for the electronics enclosure. You need my compact ALS Type 1 with optional external upgrade box. You also need a USB power supply for the ALS and a stepper motor power supply without fuses, rails, fans, buttons, switches, metal enclosure box. See my videos. Overall size is very small, especially with the external touchscreen, and is easy upgradable. Simple plug and play mounting. Touchscreen display protected is optional. Upgrade to SSV unit is optional. You need my Total Solution Compact ALS Type 2 that has internal upgrades with single power supply and protections. You only need one power supply for the ALS that also supplies power to the stepper motor driver. Overall size is even smaller than the ALS Type 1, especially with the internal upgrades.